in the function sum. In the last function, it was multiply, multiply, over divide. This one has one thing on top and two things on the bottom, so you've got to follow whatever's up there. Yeah, you can't memorize one pattern for this. That's going to be a problem.
Is everything negative in this one?
Well, we'll see. Right, like for this next one here.
Because it would be positive and a negative.
Well, when I get to -4, I've got a 0 on the bottom.
It'll be positive between -4 and 0.
Correct. Let's do a -4 first, though. -4, I've got a 0 on the bottom, so that's where I write that I have an asymptote.
The one positive 4 did it, it was negative.
And +4 will also be an asymptote,
right?
Because that's where I also have a 0 on the bottom.
It's going to be negative between -4 and 0.
Well, hang on. This is what Amy was just saying. Between -4 and 0, we have a negative divided by a negative times a positive. So that's going to be a negative divided by a negative. So that's going to be a positive. At 0, we have a 0 on top. So who cares? It's what's on the bottom. It's a 0 divided by a positive times a negative, but who cares? This is going to be negative. A positive divided by a negative times a positive will be a positive divided by a negative.
Is this going to be in our homework tonight?
I'll get to that in a sec. Not directly. And over here we have a positive divided by a positive times a positive.
Do we have to show that much room?
Not on all the homework tonight. I'll tell you what I want you to do on the homework tonight. At the end. But okay, this is how the function will behave. With this much information, I ought to be able to graph it by hand. Okay?
Why is it 2 asymptotes this time? Not
Because I had two values of x that made the bottom 0. Remember on the last time I only had one factor down here? So that only gave me one possible 0. Here I have 2 factors on the bottom. So that gives me 2 possible zeros.
okay.
There's don't memorize any one setup or arrangement of these. You got to do this differently every time. It is annoying. Everyone wants one formula they can memorize and will get them every math problem right.
Yeah.
Never happened.
The golden rule.
The golden rule. Do unto the math as you would have the math do unto you.
I just thought that.
Okay. That was. Okay. The curve passes through the origin, so I'm putting a point there. There are asymptotes at -4 and +4, so I'm putting my vertical asymptotes at those 2 values.
So it's going to be like that, and then that.
Yeah. My horizontal asymptote is the x-axis itself. So let's take a look at this. My function has to be negative. Over here, when I'm to the left of -4, my function has to be negative. It has to snuggle up to the x-axis. It has to snuggle up to this asymptote. I think it has to look something like that. Does that make sense?
Yeah, it does.
It's got to snuggle up to these things and be negative. I hope so. Now it has to snuggle up to this asymptote, and it's got to be positive heading towards 0. So I think it would have to be up here and do something like that. Is that correct?
Yeah.
And then I said when we get past 0, it has to be negative and start snuggling up to this asymptote. So I think it's got to do something like a cubic or a reflected tangent. This could be sort of like a negative x cubed.
It's a ballerina.
It is a ballerina. Then over here, it's got to be positive, snuggle up to this asymptote, and snuggle up to this axis. So it's got to look something like that. Which Amy has, but you see how what happens with this resolution is, when it gets close to the asymptote, the calculator gives up. And it's drawing part of the asymptote. That's what this is another case where you're smarter than your calculator.
Can't see 84, do that?
It all depends more on screen resolution, so I don't think so. I don't think the screen resolution is that much better between them. My software has trouble with this.
Oh.
This is a case where you will be smarter than your calculator, and because I'm presenting this to you, I will expect you to know the difference. Like if your calculator tells you to do something dumb, or that looks funny, I expect you now have the tools to double check it.
Tell your calculator.
Right. One last thing I'm just going to do real quick, because you guys were terrible at it. Horizontal asymptotes.
Thank you.
You don't have to explain the whole thing again, because I don't want to have to write a big paragraph.
No, I'm going to do something super quick, actually. Give me a sec to figure it out. of x equals.
Well, it's just what we call it, top.
Hang on, 2x squared minus 9. On the bottom, it's going to be x squared minus 6x plus 9.
So it's going to be a y for x to be 2.
Okay, yeah, hold on. Yes, my horizontal asymptote to start with. Okay, horizontal asymptote. See how fast I can do this one, actually.
Wait, I have a question.
Yeah.
Can't you factor out?
Oh, all sorts of things. But first question we get is horizontal asymptote, because we didn't do an example of this, and you guys were struggling with this one. Same degree polynomial, top and bottom. My leading coefficients are 2 and 1. If it's the same degree, top and bottom, it is the ratio of the leading coefficients, so it's the line y equals 2. You guys get that?
Yeah.
If it had been a lower degree up here, it would be it would have been the x-axis. If it had been one higher degree up here, you'd have to use long division and get a slant asymptote. Okay? So the horizontal asymptote is y equals 2. Factoring. Oh, shoot. I'm going to make this 18. My apologies. Changes nothing but makes my life easier in a minute.
Good job.
Okay. So now if I break down the factors.
If
I
I'm
get
in trouble with the question, can we just change the number again?
I'll tell you a story about that in a minute. That reminded me of something. Okay.
So just 2 of them.
Was-
Have I factored those
On
correctly?
top, wouldn't it be plus 3 minus 3?
It would be. Thank you. That is correct now. Now have I factored it correctly?
Yes.
And you
Okay.
you cancel out. Can't you?
I can reduce these,
Yeah.
okay? Except for one thing. They were in the original, so I have to acknowledge that they were there. Because this statement is not equal to this. What happens here at x equals 3?
0, 1 over 1.
I get 0 over 0. I get that indeterminate form. So-
So, -3 then.
Well, I have to draw that buttonhole there. So basically, I can graph this one. I can graph this one, but I have to remember that this one came from a case where 0 could not equal 3. I'm sorry, where x could not equal 3. So I can graph it. I can use this simpler version to graph as long as I remember to put a buttonhole here. Does that make sense?
Yeah.
I can just use this one to draw my graph, but I've got to remember to put the buttonhole there. So this one's going to look something like, let's see, what is my f of 0? So what's my 0? When does the top equal 0?
When x equals, or no, when x
Well, no, when
equals
x